Alright guys, today we're going to be covering the unit circle and everything with trigonometry that has to be applied to it, okay? Hey guys, this is just Editor Meek helping you guys out. You know I never ask you for anything, but this video really pays off if you watch till the end. So we can see it's a circle straight off the bat, but what exactly makes it a unit circle? The unit part comes from the fact that the radius of this circle, the distance from the center to the edge, is going to be 1. Okay, that's what makes it the unit circle. So when we're looking at the unit circle, we're going to be measuring our angles with respect to this line right here, this straight line, okay? So that means that if I were to measure the angle between this line right above and the perfectly horizontal line, that would be an angle of, let's say, 30 degrees. And as we continue to move this way throughout our circle, the angle measure that we are measuring continually increases. So before we go any further, I'm going to take the time to draw out all of the angle measurements that correspond to the little lines you see I have drawn here in my circle, okay? Now, it's important for you to be able to familiarize yourself with all of these because we are going to be applying them throughout the whole video, okay? First thing I want us to take notice of is that since up here on the right is our reference angle, as our reference 0 degrees, we see a perfect 90-degree angle being formed right here. And you'll see exactly opposite the 0 degrees, you see a perfect 180, a perfectly straight line, okay? As we keep going down, you see that our angle measures continue to increase by a similar pattern, okay? The difference here being that from the horizontal to the first little increment is 30 degrees, and then from the first increment to the next one is 15, and then from the next one is 15, and then is another 30. So they go 30, 45, 60, 90. Okay, and you'll see why we use that counting mechanism in just a moment. You see here, I'm at the vertical, I'm at one of the major lines, so I'm going to increase by 30, 300 degrees, then I'm going to increase by 15, 315 degrees, then I'm going to increase by another 15, 330, and now I'm back here at 0, which is my full 360-degree rotation. Now, we often use the unit circle with reference to radians. Now, if you've never heard of a radian before, radian is, for all intents and purposes right now, just a different way to measure angles, okay? So a radian, the formula is that your angle measure theta divided by 180 multiplied by pi is going to equal your radian measure, okay? And in the same sense, your radian measure divided by pi multiplied by 180 is going to equal your angle measure theta. I'm going to label all of the radian measures around the circle, and then I'll be right back. Okay, now here you can see all of the radian values placed in on my unit circle, okay? So I'm going to rewrite the formula here in case anyone needs it again, which is going to be your angle measure divided by 180 times pi equals your radians. And you can feel free to check each one individually to make sure that it does indeed obey this equation, okay? So something I don't think I quite mentioned at the beginning of the video is that the unit circle is important because we are considering it on the Cartesian coordinate plane, meaning the center of the circle is placed at the point 0, 0, okay? And since, like I said before, the entire circle has radius 1, that means if I consider this point right here, that point is going to have point 1, 0. That's going to be its location, okay? So our interpretation of the unit circle from here on out is going to be with respect to determining the coordinate or ordered pair that corresponds to each of these points right here. I draw a little line down from this top of the circle, and now you'll see we have a right triangle. This is my right angle, and since this is a 30-degree incline, it means my angle right here is 30 degrees. So if I want to find the ordered pair that corresponds to this point, I'm going to need to determine the x and y value. So let me bring this triangle out here onto the page so we can analyze it more effectively. Okay? So you'll notice I'm trying to analyze the xy pair of that point. Now, that xy pair is a combination of the x-coordinate, the distance this way, and the y-coordinate, which is going to be the distance this way. we already have two important pieces of information about this triangle. We know the radius of the circle is 1, which means this distance on my unit circle is exactly 1. Therefore, my hypotenuse of this triangle is 1. And I also know my angle measure. This angle on the left-hand side is going to be 30 degrees, okay? Now let's say I want to find the x-coordinate of my point. We can use the trigonometric functions. Let's call upon SOHCAHTOA. Ka, C-A-H, relates my adjacent side x to my hypotenuse, which I know, which is 1. Okay? Cosine of theta equals adjacent over hypotenuse. Cosine of 30 degrees equals my adjacent x over my hypotenuse 1. Therefore, cosine 30 equals x, which is equal to rad 3 over 2. Okay? So, in trying to identify the ordered pair corresponding to my 30-degree point, I now know my x-coordinate is going to be rad 3 over 2. Now, how about my y-coordinate? Let's make some room right here. How do I access my y-coordinate? Let's go through SOHCAHTOA. So, SOH relates my opposite side y to my hypotenuse, which I know is 1. Sine of my angle 30 degrees equals opposite over hypotenuse. Therefore, I can write that sine of 30 degrees equals y. And what is sine of 30 degrees? It's 1/2. So that is my y component of my ordered pair. So that is how we find the x and y coordinate of our little inclination right here, okay? Now that is an important realization to make because it allows us to make the conclusion that the ordered pair of whatever point you're looking at is equal to the cosine of your angle theta, comma, the sine of your angle theta, with cosine theta equaling x and sine theta equaling y. So now, using this very important realization that cosine theta equals x and sine theta equals y, and our ordered pair is in this sort of configuration, we can find the ordered pairs that represent all of the different points in this quadrant of our sphere. So let's do that. First, we determined that at 30 degrees of incline, we had rad 3 over 2, comma 1/2. At 45, we can determine through the same method that it is rad 2 over 2, comma rad 2 over 2. And at 60 degrees, or 2 pi over 6, we can determine that it is 1/2, comma rad 3 over 2. Now, these three values are the only values you ever really need to remember, and I'm going to show you why in just a moment. So first of all of these points that exist exactly at a vertical or horizontal line are pretty easy to figure out because our radius is 1. Therefore, in this case, our ordered pair would be 1, 0. At the top, it would be 0, 1. On the left, it would be, let me give myself a little bit more space. On the left, it would be -1, 0, and on the bottom, it would be 0, -1. Because what we need to keep in mind here is that the origin, the center of our circle, is 0, 0. But this is very important in helping us determine the rest of the ordered pairs in our circle, because remember, this is the form x, y, okay? So since we remember the shapes of the functions of cosine and sine, we remember that they are functions that repeat. And that theme is still held true here on the unit circle. So I'm going to come back after populating all of the different values of the unit circle. Okay, now you see here I've populated all of the different values of all of the different coordinates here on the unit circle. Now, what you're going to notice is that the coordinates themselves sort of repeat, okay? So here's what I mean by that. First, it goes rad 3 over 2, 1/2, then rad 2 over 2, rad 2 over 2, then 1/2 rad 3 over 2. And then the sequence reverses. And then it goes 1/2 rad 3 over 2, rad 2 over rad 2 over 2, and then rad 3 over 2, 1/2. Okay? So basically what this is trying to say is whenever we are at any point in the unit circle, we need to consider our angle with reference to the horizontal. Okay, so in this case, we have 30 degrees with reference to the horizontal. In this case, we have 30 degrees reference to the horizontal, in this case, and in this case. Okay? So these are all 30-degree measures with respect to the horizontal. And you see here that they all have the same set of coordinates. Okay? Now, what I want us to pay attention to here is where these coordinates are popping up. This set of coordinates on the left side of the unit circle are in the second quadrant. And what is negative in the second quadrant? X is negative in the second quadrant. Therefore, our x coordinate is always going to be negative for all ordered pairs appearing in the second quadrant, okay? Now, if we look at the set of coordinates appearing in the third quadrant, right down here, you'll notice that both x and y are negative in the third quadrant, which makes perfect sense. So both of our coordinates have to be negative, as illustrated right here. Okay? Then finally, we have the fourth quadrant down here. Here, only y is negative, but x is positive, which exactly matches what we expect it to be. Our x value is to the right of the origin, so it should be positive, but our y value is going down, so it should be negative. And that stands true for all values present here in the fourth quadrant. Memorizing which values should be negative and which values should be positive should be pretty easy, because we already know where x and y are supposed to be positive, right? So we know where cosine theta and sine theta are supposed to be positive. It's just an exact one-to-one switch. It's literally mirrored from x to cosine and y to sine. So let's do one more comparison example so I make sure everyone knows what's going on here, okay? We know this angle right here is 60 degrees with respect to the horizontal. Same goes for this angle, same goes for this angle, and same goes for this angle, okay? We're looking at this point, this point, this point, and this point. So if we look at those coordinates, you see that the coordinates themselves are exactly the same, just with different negative and positive values. This should be a parentheses here. Okay? It's all 1/2 comma rad 3 over 2. We use our common sense to dictate which value should be negative and which value should be positive. Whenever we're in the first quadrant, both x and y are positive, so that's reflected in the ordered pair. Whenever we're in the second quadrant, we know that we're going this way away from the origin, so our x is going to be negative as displayed right here. Therefore, cosine is going to be negative. In the third quadrant, all values are negative, so both our sine and our cosine are going to be negative. But that leaves an interesting argument to be had about the third quadrant. Because what is another trig function we know? We're familiar with tangent of theta. And we know that equals sine of theta divided by cosine of theta. Okay? So regardless of what sine theta and cosine theta are, if we're dealing in the third quadrant, they're both going to be negative. Which means if we're taking a negative sine theta divided by a negative cosine theta, that means that we have a positive tan theta whenever we are in the third quadrant. Okay? And as we go around the unit circle like this, there's a common acronym that is very often repeated. All students take calculus. All things are positive, only sine is positive, only tangent is positive, only cosine is positive. All students take calculus. Let's remember that if we want to remember how our negatives change throughout the unit circle. Alright, so let's do one practice problem. Let's say I've got my unit circle here, got my axes, and let's say I want to find the angle measure for 210 degrees. I want to find the xy coordinate for 210 degrees, okay? So first thing I do is I find the reference angle. I know 180 degrees is right here because 180 degrees is always flat. And so my reference angle is just going to be this difference. My reference angle, theta, is going to be 30 degrees. Okay? So if I want to calculate my x and y values, I'm going to remember that x, y go in the form cosine theta, common sine theta. And then I'm going to calculate cosine theta. Cosine of 30, what my x-coordinate is going to be. Cosine of 30 equals rad 3 over 2. And now I'm going to look at sine of 30, and that's going to be what my y-coordinate is going to be, which is going to be 1/2. So I know the ordered pair is going to be rad 3 over 2, comma, 1/2. Okay? So now I need to decide which is positive and which is negative. So I'm in the third quadrant here, meaning that my x value is going to the left and my y value is going down, meaning both of them are going to be negative. So therefore, this is going to be my final ordered pair representing the point at 210 degrees. But recall that this can also be represented as a triangle with rad 3 over 2 representing this leg, 1/2 representing this leg, and 1 representing the hypotenuse, where 30 degrees is present here. And recall that since this angle is 90 degrees, this angle right here is going to be 60 degrees, because our 30 and our 60 must always add to 90. Okay, the two remaining angles in a right triangle must always add to 90 degrees, which means that in this particular instance, we're dealing with a 30, 60, 90 right triangle. Okay, and it obeys exactly the rules that a 30, 60, 90 should. We have x, 2x, and this side should be x rad 3, which if we set x equal to 1/2, everything plays out very nicely. If you guys ever have questions, just join the Discord server. In the meantime, enjoy life.